Good morning, students. So today, in the second part of your shaft, we will see shaft subjected to your combined twisting and bending movement and design of shaft on the basis of rigidity. Okay. So first here we will see shaft subjected to combined twisting and bending movement. So here we will see the maximum stress theory known as your test theory and your maximum normal stress theory, that is your Rankine theory. Shaft subjected to combined twisting and bending moment. First we will see your tau is equal to shear stress induced due to twisting and sigma b, that is bending stress induced due to bending moment. So here, as we know, we have seen in your previous slide shaft part 1, that is your t is equal to pi by 16 tau d cube. So t into 16, that is pi into tau into d cube. So tau is equal to t by 16 divided by pi d cube. Therefore tau is equal to what? T into 16 divided by pi d cube. So we are getting the value of tau. Similarly, in case of your m, so this is your, when we have seen bending moment only, so we are getting m is equal to pi sigma b d cube by 32. So pi m into 32 is equal to pi sigma b d cube. So sigma b, we are getting the value sigma b as m into 32 divided by pi d cube. Sigma b here is equal to your this value. So according to your maximum stress theory, we know shear stress maximum is equal to what? 1 by 2 root over of sigma b square plus 4 tau square. Okay. So substituting the value of tau and sigma b from equation 1 and 2, in this equation we are getting what? As tau max is equal to 1 by 2 into 32 m divided by pi d cube plus 16t divided by pi d cube whole square. Okay, so if we are taking this to 4 as 2 square, so this is 16 into t pi d cube. So this 2 square and 16 square, it is getting inside the bracket. So 2 into your 16 whole into t square divided by pi d cube. Rest is the same. So 16 into 2 is your 32 into t whole square. So here we can see 32 divided by pi d cube, and here also 32 divided by pi d cube. So I am taking this as common, and root over of 32 pi d cube is yours this much, 32 divided by square. Okay, pi 32 divided by pi d cube square root over is equal to 32 divided by pi d cube. So this 2 is getting cancelled for this. So we are getting 16 divided by pi d cube into root over of m square plus t square. So this whole term is getting multiplied here. So we are getting pi divided by 16 tau max into d cube is equal to your what? Root over of m square plus t square. So this m square plus t square is known as your what? Equivalent twisting moment, and it is denoted by T. So it is defined as the twisting moment which when acting produces shear stress tau as the actual twisting moment. Okay. So here TE, what we are getting? TE is equal to what? Root over of m square plus t square equal to pi by 16 tau d cube. So next we will say, according to maximum normal stress theory, you know what? Sigma b is equal to sigma b max is equal to 1 by 2 sigma b plus 1 by 2 in sigma b 1 by 2 root over of sigma b square plus 4 tau square. So putting the value of sigma b and tau from the above equation 1 and 2, what we are getting? 32 m pi d cube plus 1 by 2 32 m divided by pi d cube whole square plus 4 into 16t divided by pi d cube whole square. So once again I can take pi, uh, 32 divided by pi d cube here common, and here also we are seeing that 32 pi d cube common, and this if I am multiplying once again we are getting what, 32 pi d cube common. So I am taking this term as common. So what I am getting, 32 pi d cube common into 1 by 2 as common. So 1 by 2 is 1 by 2 is also common into your m plus root over of m square plus t square. Okay, so if I am dividing this whole part, this whole equation, this whole term into other side of the equation, that is sigma b max. So what I am getting, pi into d cube divided by 32 sigma b is equal to what, 1 by 2 into m plus root over of m square plus t square. So this, the expression 1 by half into m plus root over of m square plus t square is known as equivalent bending moment and is denoted by your me. Okay, so this is defined as what, that moment which acting alone produces same tensile or compressive stress sigma b as the actual bending moment. So we can write down me is equal to 1 by 2 into m plus root over of m square plus t square, that equals to your pi by 32, in turn pi by 32 into sigma b into d cube. Okay, so it is, when this is your equivalent bending moment, so it can be defined as that moment which one acting alone produces your same tensile or compressive stress as your actual bending moment or your sigma b. Okay, next we will see from the equation ME is equal to this much for hollow shaft. So as we know, for hollow shaft we have two diameters, that is outside and inside diameter. So in place of D, the term is getting d0 cube whole cube into 1 plus k. Similarly here sigma b into d0 cube, in place of your d we are just um, putting d0 into 1 plus k, and k is what, ratio of di by d0. So for hollow shaft t is equal to this much is equal to, in place of d we are just replacing as d0 and 1 plus 1 minus k. So this we have this term, this part of hollow shaft you have already seen in your previous slide. So I am not explaining it. Directly I have written pi into tau d0 cube into 1 minus k to the power 4. Similarly this is same, pi by 32 sigma b d0 cube into 1 minus k to the power 4. Okay. Next, the maximum shear stress theory is generally used for ductile materials such as your mild steel, and maximum normal stress theory, that is your Rankine theory, is normally used for, it is used for brittle materials such as your cast iron. Okay, next we will see design of shaft on the basis of rigidity modulus. So torsional deflection is given by the equation what, T by g theta equal to j by L, or we can see say theta is equal to T into L divided by j into g. Okay, so here what is your theta? Theta is your torsional deflection, deflection or angle of twist in your radial. Okay, so in case our camshaft or an IC engine where timing of valve should be affected, the permissible value of theta should not exceed 0.25 meter per length of shaft, and for your line shaft deflection of theta that is between 2.5 to 3 degree per meter length, and this is the may be used as your limiting value. And the widely used deflection of shaft is your limited to 1 degree per length, in length equal to your 20 times the diameter of shaft. So here theta value can be determined by this equation of torsional deflection, that is T by J is equal to G theta into mm, G theta divided by L. So theta is equal to T into L divided by JG. So where theta is equal to what? Torsional deflection or angle of twist. Next your T is equal to twisting moment or torque of the shaft. Next, J is equal to your polar moment of inertia of the cross-sectional area about the axis of rotation, where J is equal to what? Pi by 32 d to the power 4 for solid shaft, and J is equal to pi by 32 d0, that is outer diameter minus your inner diameter, whole to the power 4, and then d0 to the power 4 minus di to the power 4 for your hollow shaft. Next, J is what? G is what? Modulus of rigidity of the shaft material. L is the length of shaft. So this is all about your shaft for this shaft chapter, and next class we will see some problems based upon your combined torsional combine when the shaft is subjected to combined twisting and bending moment, and design of shaft on the basis of rigidity modulus. Thank you.